आइए हम सुने विज्ञान की अनकही कहानियां।
Most of us never even think about the ground beneath our feet until it moves. This scientist from WADIA Institute of Himalayan Geology studies how the Himalayas' tectonic engine shapes landslides. His work helps engineers design tunnels, farmers protect terraces, and towns plan evacuation routes during monsoons.
I am Dr. Luirei. I've been working in WADIA Institute from 2003. I did my PhD from Kumaon University, Nainital, and my specialization is in near tectonics and landslide. And I did my PhD from this DrKhayingshing area. Yeah, this is my specialization is in this one, landslide and tectonic geomorphology. Tectonic geomorphology deals with landform produced by active tectonics, and landslide, as we know, is downslope movement of soil or rocks. Tectonic geomorphology, it deals with landform produced by this one, recent tectonic activity. Because as you know, Himalaya has been formed because of a collision between two plates, erosion and indent plates, and the deformation is still going on. And then previously, at first, the deformation started from this one, MCT. Later on, it moved southward, and then the active deformation front was this main boundary thrust. Now, at present, it is the HFT, Himalayan Frontal Thrust. And then here, the recent tectonic activity is evident from many landform evidences, such as fault scarps, uplifted terraces, nick points, linear valleys, and so on. So that's, and then for that we have to identify the area, and then after that, whether it is active, we have to use chronology also. We have this OSL dating, carbon dating, and so on. So at present, I'm working in this Kalayam area of HFT, this near Yamuna Nagar. There, I'm working on it. And then apart from that one, I'm working in landslides also. Landslides, I'm working in this two areas. One is along the main boundary thrust, and the other is along the MCT. And then here in the Himalayas, the landslides are concentrated along to these thrust zones. This is along the MPT and then the HFT. And then here the width of the active zone ranges from 5 kilometer to 20 kilometer, based on the active landslides and paleo landslides. And as we can see, that means in Himalaya, most of the settlements are either in river terraces or in landslide debris. At present, my student and myself, we are concentrating in this identification for landslide damming sites. Because landslide dam is after it breaches, it has a cascading effects downstream, as we have seen in these Rishikanka events. And then in 1978 also along this Kanodia Kar in Bhagirathi Valley. It is 25 kilometers away from Uttarkashi, upstream of Uttarkashi. And then when because of landslide, the Bhagirathi river was dammed for around 3 to 4 hours. And then when it breached, the side effect was even felt up to Uttarkashi. So looking at this aspect, we have identified some valleys where landslide can be dammed, where the stream can be dammed. And then it depends upon the nature of the valley, the size of landslides, and the gradient of the streams. So based on that, we are trying to develop a model so that in case a certain portion of the valley is dammed, so if what will be say we are just modeling, say amount of this much amount has been dammed, and then how far it will reach, how far it will affect. That will be a societal, that's what we are doing. Yeah, when I joined here in WADIA Institute, my first posting was at Arunachal Pradesh. We had a unit out here, and then I was focusing mainly on this tectonic geomorphology. And then after that, I came here and then I studied this again here, the same aspect on it, this landslide and this tectonic geomorphology. Now my future aim is I want to carry out along this Shubenpal of Nagaland. That is the least explored area in terms of tectonic geomorphology. Here in western part of this Himalaya, many works has been done. So now I want to focus along this Naga Thrust and some portion of the Siang Valley for landslide investigations. Okay, in terms of tectonic geomorphology, among the 2,214 institutes working in tectonic geomorphology, we are ranked third. We are performing very well, and then we are third, and then our institute also is ranked third in this case. And then in this case, some of my colleagues, my friends also, they are among the top workers. Professor Kothari, Professor Chamyal, Professor Pant, they are listed among one of the prominent workers in tectonic geomorphology. Yeah, ahead of us is China and US. They are performing, their ranking is higher, so we have to compete with them. I have published some in Geomorphology, Journal of Geomorphology, International Journal of Earth Sciences, and then this Geological Journal, and then Geosciences Journal. And these are some of the few journals that I have published. I think this is a very good initiative because many people doesn't know what scientists are doing in the labs. So through this, I think the message will be they'll know what researchers are doing.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.